Okay, who wants to talk for Taffy? You done with it? Are you ready for it, Lincoln? Go for it.
So we did the C
Mm-hmm.
one, so we did 20, C 3, and we got 11, 40.
Okay, obviously besides this is the combination section, how do you know that it's gonna be a combination for this? Why does order not matter in this problem?
Because it doesn't say anything about order.
Right, it doesn't say anything about order. If it said something like, how many ways can you choose a president, vice president, and secretary, that would mean order matters, because you care who, it's not like if you elect people in the country, and they're like, hey, on the ticket is, J.D. Vance and Donald Trump, and you're like, great, I'm gonna vote for them, and they're like, yeah, which one's gonna be president? You're like, doesn't matter, just either one, just, they'll decide when they get in there, like, no, you're voting for a specific president, a specific vice president, right? You're voting for specific people in these roles. You're not necessarily voting for just whoever. So if it says specific roles, that's when you care. But this one just says it's just 3 people. So 3 people. Great job. Lincoln, go grab a candy. So let's look at example 3, which is exactly what I'm talking about. A student advisory board consists of 17 members. The 3 members will serve as the board's chair, the secretary, and the webmaster. Each member is equally likely to serve in any of the positions. What'd you get? Is it a swirl? Oh no, it's like half and half, huh? Maybe juicy pear or pineapple whip?
Definitely
So this one, order does matter. It says, what's the probability? So first of all, it says, what's the probability? So instead of just having a number this time, we're gonna have a percent or decimal of selecting at random the 3 random members who currently hold the 3 positions. So the choices are 17, this is a permutation because we do care about who is in what role. So everybody type in 17 permutation 3 in your calculator. So there are like 4,080 choices of who could be president, or chair, secretary, and webmaster, but there's only one thing that would match it. So it's only 1 out of 4,080, which would be 0.000245. That's your chances of just randomly selecting the correct chair, secretary, and webmaster. Okay, now we're gonna get a little pokery, which is the stuff I enjoy. Find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards without any like swapping out. Okay? All right, so it's gonna be a probability, so it's gonna be a fraction. How many, okay, I guess the first question is this. Is it a combination or a permutation when you're selecting poker hands? Does the order in which you pick the cards matter? No, because when you've got 5 cards in your hand, it's not like if you had a royal flush where you're like, I've got a king, ace, a 10, and a jack, and a queen. And man, if they were just in order in my hand, I would have gotten it, but I can't put one here and one there, so I guess I didn't get it. Like, you can move cards around in your hand in any card game. So it's a combination. So on the bottom, as far as choices are gonna be 52, combination 5. We're picking 5 cards out of 52. You can come in. But we only want diamonds, right? So how many diamonds are there? 13. So 13. Again, it doesn't matter what order we pick them up in, and how many do we want? 5. Okay, so in your calculator, put this in. You don't need parentheses at all. You can just write 13 combination 5 divided by 52 combination 5. Mm-hmm. What does that e to the negative 4 mean again? Decimal gets moved 4 places. 1, 2, 3, 4. So it's 0.0004952. So are the chances very good to just get diamonds, all 5 diamonds, without doing any swaps? Nope. It would actually be 0.04% of the time, or 0.05% of the time that would happen to you. Although you could multiply that by 4 if you were just like, well, it could be hearts or spades or clubs, if I wanted 4 in a row, or 5 in a row. No worries, come on in. Find the probability of being dealt 5 diamonds that also includes 2 jokers. In this case, the joker is considered to be a wild card that could be used to represent any card in the deck. All right, we're not going to do this as partners. I just want to talk to you guys about it. So does anybody want to take a guess at this and get a prize for it? Think about what would change. Sure, go for it.
On the bottom it would be 54,
Mm-hmm.
C5,
Yep.
and then on the top it would be 15. Or,
Yes. 15, choose 5, because now you got 2 extras that could be considered diamonds, right? That's perfect. All right, go ahead and put those in your calculator, and you should go get a prize. Point 0.0009496. So if you add jokers to the mix, more likely or less likely that you'd get all diamonds?